Blah, 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 blah. Just look at the table for a second, and I think you can learn a lot of things from this table, okay? Table. I have no idea what any of the words, and there's a lot of words up there, don't care. Here's my prediction. I bet they're going to make me center series at 3. I bet they're going to make me build P, this is my prediction, and I might be wrong, but I might go to P3. Why did I stop at P3? I'm guessing. Why would I maybe stop at P3? So then I could use my air on the 4th. Or they're going to make me build P4, but then later when they talk about air, they're going to be randomly like, I just discovered that the fifth derivative is guaranteed less than this number. And you're like, oh, why, thank you. That's a nice K. Cool. Prediction. I have no idea what's going on. Next prediction. Bonus point. Do I have a max min saddle or none? None. How do I know? Well, I heard a lot of second and first. Which one do you start with first? First derivative is -10. So I don't have a max min or whatnot. Let's say this was a 0. Then I have a what? Min, because I'm concave up. Okay. I know because I looked at it. They asked you randomly later about do you have a max min or saddle at 2.5? Okay. Where am I centered at? What do I know for sure at 3? I have a slope of -10, so I don't have a max min or saddle at 3. But when they ask me about 2.5, I'm like, why are you asking me about 2.5? Do I know everything at 2.5? The only way I would know everything at 2.5 is if you made me build which series? Well, good. The 2.5 series or the infinite series. If I build the infinite series, do I own everything? But what do I do? Build the 4th series? 4th degree? So do I know everything? Nope. So your little answer to the 2.5 one would be like, look, I'm centered at 3. I have details at 3. At 2.5, everything I'm doing is an approximation, and I don't own the whole series anyway, so I can't tell you anything. I'm just giving you previews, but hit me, Clement. I just unreleased them this morning, so you can go back and look. I unreleased, so then you can, I think, relook at your stuff. Did you refresh? I just did it while you guys were doing the AP thing. I just did it. Thank you. Okay, I submit. All of those are. There you go. Now you can see it. Okay, here we go. Hey, I reopened it. I think that's what I forgot to do. Okay, right equation and tangent line at x equals 3. Okay, Calc 1 style, I'd be like this. Okay, my point at 3 is 3, 6. Slope equals -10. Y minus 6 equals -10 x minus 3. That's how I do a tangent line. But you might have been like, this one worded it as a tangent line, but this is also P1. If you wanted to do it in the P1 style, where am I centered at? 3. And my values of blue are 6 and -10. That's how you would see it as a P1. I wrote it as a tangent line. Just look at that. Are they the same? So it's the same thing that happened to you guys on the very first question. Very first question, number 1. The very first part A said, write the first order degree, I think, something like that, P1, which is me saying tangent line. And approximate 2.5, whatever. You can plug in 2.5. B, use it to approximate 2.5. Check. Is there enough information to determine whether it's a critical point at 2.5? Where's my data at? 3. Do I have any exact data at 2.5? No. Do not even do this. Could I take his derivative, plug in 2.5? Could I do that? Whatever you get there, is that the exact slope there? No. Is it an approximation slope? So I don't even care if that approximation slope is 5. Does that mean the real slope is 5? Nope. If I take the derivative and the approximation slope is 0, does that mean it's a really 0? No. So what are you going to say before you even try and do any math on this? I have data at 3. Since you want me to talk about 2.5, it's an approximation, so I can't guarantee you anything. Good? Okay, so I just said that one out loud instead of writing it. Okay, C, fourth derivative of f satisfies hello, K. Use the Lagrange error bound to show the approximation found in part B differs from 2.5 by no more than 1/8. Okay, rephrase it. Prove to me your hug is 1/8 or smaller. So on part C, my error, and I'm trying to be 1/8. Okay, I stopped at degree 3, so I got 4 factorial. I stopped at degree 3, so that's 4. I am centered at 3, and I'm plugging in 2.5. Good with that? And K. K. Hey, 48. Good question. So, very good question from Jaden. What is the definition of K? Let's write definition of K down. K, max, fourth derivative, in between 2.5 and 3. You guys okay? That's what you normally pick. What's the 32 represent? The 32, the fourth derivative value at 3 is 32. Okay. And then it says for everything greater than 2, so it's like this. This guy's worth 32. Do you know what this guy's worth? Don't know. Could he be 50? No, he cannot be 50. Because it's less than 48. Could it? I know. I just had to trick you. Could it be 30? If this is 30, I'm taking the 32. Could this be 40? Then I take the 40. But if I don't know if 32 is the best between 2.5 and 3, I don't know. Can I just play it safe and go whoop and use the 48? That's what you get on C, and it will be less than or equal to 1/8. It is 1/8. Okay? D, what is the coefficient of the x minus 3 cubed term of the Taylor series for f prime, the derivative of f? Okay, on D, it's kind of like, what, dude, I don't have the third degree term. I only have the first degree term. Do you agree it's kind of annoying on D that I'm actually going to kind of rebuild this thing back up and then take a derivative? So help me out. Which guy do I really need to build up? Do I need to build all of it or just one guy? One guy. And the guy I'm going to build off of this, and I'll explain why. You might say, why are you building the fourth degree dude when it says the third degree dude? What am I going to take with the fourth degree dude? His derivative. So on D, I'm like, all right, let me first take this guy. That's the one dude that I'm going to take his derivative of. And now if I take his derivative, I get 32 times 4 x minus 3 cubed over 4 factorial. 32 over 3 factorial, x minus 3 cubed. 32 over 6, x minus 3 cubed. All of these are correct answers. I'm just writing out something that you might have written. Let's see, did it say just coefficient or what was the term? What is the coefficient of that term? Full point, full point, full point, full point. For AP. Because is this what I circled? Is that an exact answer? You can do some simplifying, but it's an exact answer. Kind of like, what's 4/8? 1/2. Is 4/8 equal to 1/2? So if you say 4/8, can I say you're wrong? No. Yeah, 1/2. Good.
So if AP they then tell you to simplify everything.
Yeah. Yep. Yep.
I don't know if others do it. For B, were they not asking for this? Were they just asking about whether it was a math or
so on A you had to, oh yeah, sorry. I didn't do this part. You were supposed to do this part too. Yeah, you could build more out. Yeah. Cool? Okay, let's look now all the way back up at now we're going back to slide 1 and beyond. Okay. Okay, first thing, K. Last couple days I talked about K can come from a graph, can be a formula, come from a table. It could be given to you, like on that question 15, we're like, I don't know. Yeah, let's say it's 48 or less, and you're like, thanks, I have K. Or you have to take it and take derivative. This is, someone came in this morning and talked about that square root of 3.9 guy again, where we had to take derivatives and then choose our K all by ourselves. And then in this problem, are you okay? It's coming from a table. Clearly there's a table. I bet there's going to be some question about air. Another prediction here. I bet somewhere they're going to say this, build P3. Why not P4? Because I need the next guy for my air. So they might build P3 at 1 or at 2 or at 3. So far, okay? Next idea. Maybe they say, build P3 centered at 2, and we're going to approximate 3. Are you okay? I circled these two because those would be your two choices for K. Do another one. Let's say I want to do P3 centered at 1, and I want to approximate 2. Are you okay? Those are my two choices for K. Okay? Word it for me. What would those two choices come from? If I built what? P2 centered where? 2 or 3, and evaluating at the other one. You guys okay with that? All right, here we go. Write the first degree Taylor polynomial for h about x equals 2. The way you read that is that. The way I read it, what's a synonym for first degree Taylor polynomial? Tangent line. I know you didn't write it in red. I know you wrote it this way, but just look. They're saying, I want to make sure you realize that again. What did I taught you Taylor all year. I taught you the 3-color system all year, but I taught it in the fall as only P1, and I taught it as point float form. But the point float form is just the P1 version of the 3-color system from now. And now we can do tangent lines, parabola, tangent parabola, tangent cubic, tangent forevers. Okay. And then it says part A, finish it up. Why am I an under or an overestimate? Explain. How did we explain air back in the fall? I didn't talk about Lagrange. I didn't talk about alternating series. The only way I talked about air in the fall in my concave up, which means my tangent line's an under, or my concave down and my tangent line's an over. We talked about air in fall. I just was very vague with it. So this one, since the second derivative is positive, I'm concave up. That's why my tangent line's underestimate. How's that? Okay? Here comes that Lagrange dude. Use the Lagrange air bound to show that the third degree, check. Centered at 2, check. Ooh, this was a curveball. I thought it would be centered at 2 going to 3, or centered at 2 going to 1, but where does it want me to do? Centered at 2 going to 1.9. So my scale is almost like, let me, now do you agree it only highlights one number, but I'm very nervous or curious about another number? Do I have the number at 2? Who do I not have the number at? 1.9. So now I'm like, well, I guess that the only number I have is 584 over 9. But how do I know that 584 over 9 is actually the biggest? And there was a line that was written that a lot of you probably ignored because you're like, why are they talking to me so much? That line. Read that, and I think it now will make more sense to you that as you go right, what happens to all of my derivatives? They keep increasing. So if I had a choice between 1.9 and 2, and it's always increasing, it's always increasing. You understand that I'm going to use the 2. The biggest one, which is the 2. The better question that I like is what happens if I say, same thing, but let's say not approximate at 1.9, let's approximate at 2.1. If you're doing 2.1, so you're like, is it this or 2.1? Well, if it's always increasing, who am I supposed to take? 2.1. But what's the dilemma? I don't have 2.1. So you use the 3 guy. Because if I don't have the 2. I want the 2.1. I want him right there, but I don't own him. Is this guy smaller? If he's smaller, then can you guarantee it anymore? Or are you like, oh, don't go smaller. I got to go bigger. Well, what's the next guy I own? I don't own 2.1 or 2.2 or 2.3 or 2.4 or 2.9, but I own him. Did I circle it perfectly? Okay. Okay. So your air would have been these 3 colors. Okay. Next. Oh, sorry. And then if you calculate that, that's going to be better than or equal to this. I did use the 584 over 9. Yep. Oh, in my made up example, it would have still been 2.1 minus 2. That would never change. Remember, yellow minus centering, wherever I'm centered at, so minus my center, and what I'm trying to evaluate at. Yellow doesn't change.
When we said we were going to use the 3, the x equals 3 for the fourth derivative.
I think I talked too quick. I'm saying if you wanted to approximate f of 2.1 using third degree, the air, no choice. What's the bottom? Third degree, so air. No choice, yellow. I was still centered at 2. Where am I now going? 2.1. And then for the K, technically you say K is my max of fourth derivative between 2 and 2.1. Who should I take? He's bigger, but I don't have him. Yeah, you don't change the yellow. Yellow stays fixed. I could then say, fine, let's just make K 100. I don't know, let's call K 100 and go big. Or I can say, fine, I'll use K to be 1125/16. Better? Okay. Next one. We still got more? No. Yeah, okay. Just straight up. 3 color. You want this problem on the test. If you debate about which problems were tricky and which problems weren't, this one wasn't. 3 colored system, go get your blues. Yellow and green never change. I don't know. Then I did something wrong and first hour never told me I was wrong. Did you say 1/32 or 1/64? You had 6. Okay. That question. Okay. Are you guys okay? This one, there's no trick on this one. If anything, if you messed up, it's like computing it, not I don't know what to do with it thing. Is good? Yeah. And you're like, thank you. I love this one. Yay. Okay. Now remember, is this to me, is this green for tomorrow? In May, it might not be green because you might be like, oh, a memorizer, not a boomerang, oh, overhand boomerang, underhand boomerang. What was the boomerang again? I don't even. Then he showed me Mickey Mouse eating corn, and then wait, he showed Pluto eating the boomerang and 3 colors and K, and then there's a Kiwi movie. Hey, this is a red problem now. So. All right, next one. We had fun with this one because this one was a badly worded answer. Okay, so for me, what I first did was I noticed A and B are the same guy outside of the wording at the end, and C and D are the same guy. So me, the math guy here, I didn't read the wording. I just ignored the wording at the end, and I'm like, is it the AB dude or the CD dude? How's that? And on the AB and CD dude, they all say 8. They all say this. It's all about 12, 12, 6, or 6. You guys see how I want to go about that second dude, the second term. Is it 12, 12, or 6, 6? Okay? That's what we're trying to figure out. So what do I do? Check, check, check. At 2, I get 12. Ooh, so if I get 12, what color is this? Let's if I get 12, does that mean it's these 2? No, that means blue is 12. So when blue is 12, 12/2 factorial makes me 6. So you good with it's either C or D? How's that? Okay, now, so I'm hoping you chose C or D. Okay, now, I think this is what most chose. Okay, because normally we say this. Did I build P infinity? Not. I just built P3, right? I didn't build P infinity. I built P3. So if I build P3, then it's where am I centered at? 2. So I'm exact at 2, and I'm approximating to the right of 2 and to the left of 2. Now, what would be a better guy to look at, 2.1 or 2.8? 2.1. So do you agree it should be like this? I'm perfect at 2. I'm pretty good. Okay. Worse. Not good at all. That's kind of the idea. And then if I go to P infinity, what happens? I'm good. Good. So, wording wise, first hour first said, look, T3, that's not T infinity. So I should be pretty good around 2, and that's it. That's what that they worked with. And then Andrew raised his hand. He's like, whoa, Bob. You're trying to approximate x cubed. X cubed is a cube function. And if I built P3, isn't that the cube representation of the cube function you want? Shouldn't that be him? And everyone's like, oh. If you do square root of x, can you end at P3 or P4 or P5? No. Inverse tangent? No. E to the x? No. Sine? No. Cosine? No. But if you want to build an x cubed guy, how far do you need to go for exactness? 3. So then they're like, okay, Andrew, I guess you're trying to get this guy. And then someone else raised their hand and said, I don't like how they worded that then. Because if you built P3 and you're telling me that's sort of like P infinity, because, I mean, what would happen after the third derivative? 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Like, it is perfect. What word is messed up on D then? Approximation. Now it's like, dude, if you're telling me you're good everywhere, then quit telling me I'm an approximation. It should be, this guy is this guy for all real numbers. And then they're all like in a doozy. Doozy? Woozy? So then, look what I typed in. Typed in x cubed. I typed in the Taylor P3 or P3 approximation for this guy. Now, what is this line showing you? The real minus the approximate. So what's this getting you? The real error. And then I slid this. So what do you think happened when I slid it? 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. So is the P3 exactly him? Okay? You can call AP. I didn't write this one, so I don't know what. What? Is it super rare that they messed up their wording? Rephrase. I really like this. How about this? This is me being Mr. AP. True or false? To approximate x to the 5th minus x cubed minus x plus 8. Keyword, I said x to the 5th. Okay. Let me rephrase. To build a random x to the 5th dude using Taylor, I can build it exactly using P5. True or false? That's a better way of phrasing this whole question. Can I build a P5 and be exact for an x to the 5th? That'd be true. But if I say, hey, I have an x to the 5th and I build P2, now it's an approximation. But we've been so trained that P1's an approx, P2's an approx, P3's an approx, P4's an approx, P5's an approx. When do I finally get to say not approx? At P, for any problem, P infinity. But that's because we've been doing square roots of x, ln, inverse tangents. But if I just say, man, how do we like build something for x to the 8th? Well, P0 through P7 are all approximations. P8 is exactly him. What would P9 be? No, what would the whole P9 be? The same thing as P8, because what would be the 9th blue number? 0. Better? Okay. Maddie, question? I don't know. I have no idea. I think this is the better one. This isn't true. The part I don't like here is this isn't true. So I think too, this my AP classroom thing, I kind of think these are like the junior APers. There's like, hi, I am real AP man or woman, and I build the real AP test for May. And then there's this guy's like, hey, I'm in the minor leagues. I would like to be in the major leagues. Let me try and build a question for you guys and see if you like it. Okay, because it's worded bad, really worded bad. So this was not on the 2018 official test multiple choice. This was on extra problems that they made. That's fine. Okay. Here we go. Yep. You got that. Okay. Easy. Do I need to do anything? Questions? Straightforward. Green, green, green. Go, dog, go. Have that in your head tomorrow. Go, dog, go. The light is green now. Stop. The light is red now. Yeah? When was the last time you read Go, dog, go? Go, dog, go? Whatever. Oh, okay. All right, here we go. This question and the 1, 2 from here was the most asked one when people try to ask me questions. So question 6 and question 8 were questions a lot of people asked. Let me reframe your brain. I answered this question on the Monday last week. Why do you forget it? That was a week and a half ago. There's 2 ways to solve this problem. One way is to think about the 3-colored system. And the other way is if I show you that. If I show you that, I think stuff floors back into your head. Oh, I remember this. So I'll do it this way first. This is the first way I taught you. Okay. Yellows, green, blues. Are you good? I wrote some more out. I wrote some more out, but I just used the formula guy, and I wrote some more out. How's that? And the question, let's just do this one. F of 17. So you want me to take 17 derivatives. That seems like forever. Whew. What happens to any guy in the yellow group? They go away exactly to 0. Like, this guy goes away to 0 right away after 1 derivative. This guy takes 2 derivatives. It's like number, then 0. This guy's like 2x over 6, 2 over 6, 0. This guy goes to 0 at the very last moment. Cool. So they all go to 0. What's blue guy do? Any blue guy. You take the x to the 100th, dude. What does the blue guy do? Sort of goes to 0. You are right, but why does it go to 0? Because you get to plug in 0 for x. So for the blue guy, they still have x's in them. Like if you do the x to the 100th, dude, you take 17 derivatives, you're going to have like x to the 83rd with some random numbers in it. But then I get to plug in x equals 0, and that whole blue poof goes away. So the yellows terminate at 0. The blues still have lots of x's in them, but then you plug in 0. And what happens to the one green dude? He stays alive. Ha, 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 ha. Right? Were you thinking that too? Do you do that when you swim? Or you like, ha, 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 staying alive, staying alive, staying alive. Doo-doo. How's that part go right after that? You do? Different songs? Okay. 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 What happens with 17 derivatives? 17, 16, 15, 14, 13, 12, all the way down to 1, x to the 0. So then I have 17 factorial left on top, the 18 factorial on the bottom. That cancels to 1 over 18. That's one way to do it. And I asked first period, and it seemed like a lot of them were like, yeah, I remember this way. I like this way. Cool. Go. You could have been 17 factorial over 18 factorial. You'd only have to simplify if it was like multiple choice. And you're like, which answer is this? Josh? Okay. Next way. Okay. If you want me to talk about the 17th derivative at 0, to me, that's the blue initial condition on that 3-color system. How's that? This is the second way to do it, and some of you might prefer this way. If you say this is what normally happens if you want this guy, he gets paired with 17 factorial and this. How's that? Okay, pick for me. Help me, I want the 17th dude. Who's the 17th dude? X to the 17th over? Okay? So, the key to it is what they wrote was blended. What they already did was they took your blue and your green and they simplified the blue and the green. And they made a maroon. But is the X still there? Is the yellow unchanged? X, X squared, X cubed, X to the fourth. They don't touch the yellow, but they simplify blue over green to make maroon. So, the way you would have done it is a 3-color system. They already did the 3-color system and simplified it. So the yellow remains unchanged. Now how do I solve? What do I need to do? The yellow is the same, so what do I need to do to get blue? Solve the algebra 1 question. How do I get rid of divide by green? What, hey, is the yellow the same? Solve for blue. Multiply the green over. Are you okay with that? Are you okay with that? Okay. So, I have a feeling, clearly at least from Connor, because Connor made that very loud groan, that Connor chooses this way. Totally fine. What way do you choose? A personal question for you. Are you, let me make my 3-color system match their blended system. Or let me write yellow, 1 middle green, lots of blue, 0, 0. Let's talk about you. Did you feel Dr. Seuss coming out? So let me skip number 7 real quick. And let's go to number 8. So number 8, I asked them, I said, which way do you want me to solve then? They're like, yellow, green, blue. So Ryan, you do it your way. Okay. I'm going to go, what's up? Which one? Zach, hit me. Oh, we're going to all. Yeah. Okay. Okay. So I wrote it the way they wanted me to write it. The key to it, since it wanted the 30th derivative, you agree I need that dude. I need the thing to the 30th. Everything short of it, what's going to happen to them? 0. This guy over here won't go to 0. It's going to be left with like x minus 3 to the 70th. But then when I plug in 3, what's 3 minus 3? So the only guy I'm worried about is this guy, and I need to take 30 derivatives of him, which means 30 factorial falls in front. So I get 30 factorial, x minus 3 to the 0 over 15 factorial, e. Okay? You're blended, you would have had, hey, you're blended, blue over 30 factorial equals 1 over 15 factorial. Move the 30 factorial over maroon. Okay. Back to 7. I know you want 9. Okay, first comment. All of those, do you see factorials on the bottom? Are there factorials there right now? No, so you're like, dude, where's blue over green times yellow? What's going on here? Do you see the yellow? X squared, x cubed, x to the 4. Oh, good, you don't touch my gold. X's, gold, yellow, untouched. But since you don't see factorials, are you okay that they've already simplified my green over my blue over green? So when you're trying to get the answer, I would just go build my 3-colored system and then look to see which one matches. That's what I would do. First thing, I plugged in, I found. Okay? Okay, there is 7. Should we skip 9 for now, or? Okay. Okay. First thing. Okay. At 2. Don't tell me a number, even though it's up there. At 2, what's the value? something, true, a positive value. Well, apparently, what's the value? 2. Do you agree they all say 2? So that doesn't help me. But then I finally put the 2 in there. They did this on purpose where they didn't label the axis because they didn't want you to try and get, like my next question, what's the blue worth? What's the slope worth? Positive. Do you see how without the scaling of the y-axis, you can't call this 1 or 2 or 3 or 1/4 or 1/5? They just wanted you to know that the blue slope is positive. So, what better be next? Positive, a plus. Okay, so apparently that one's wrong. Good with that? And you might say, why are these 2 wrong? Well, I'll tell you why. Those were wrong from the get-go. This says centering at, where are these centered at? 0. So these are centered at 0, bad boys. I don't want them. These are all, look here, these are all centered at 2. Do you see x minus 2, x minus 2, x, Zach, you see my x minus 2s? Good with A, B, or bad?
Yeah, no.
Okay. Next. Okay. Oh, good. I got a plus and a plus. All right. They're the same. Next thing. What's the concavity of this thing? Up. Positive. Concave up. E. Okay. If you wanted to know what D would have had to be, here's what D would have had to be. Do I have a positive value there? Do I have a positive slope there? But I'm bent down. So that's a plus, plus, minus. This one here, I have a positive value. I have a negative slope. But then I'm concave up. So that's a plus, minus, plus. Zach, how'd I do on your 9? Good. 10. Okay. Right, second degree Taylor, 3 colors. Boom, boom, boom. Green never changes. Yellow never changes. The reason I wrote x minus 1s is because it's centered at 1. Then I'm like, okay, I need to get my blues. Okay. Now, at 1, degree at 1, they gave me that initial condition. The first derivative is 8. And you're like, dude, that's only for the first derivative. I need 15 and 20. Oh, it told it to me in the statement. Okay, is that kind of similar to your the one that we just did in 2019? The 2019, did they give you what? Blue for 2, blue for 3, blue for 4, and then 0 and 1 came from the graph? Here, I guess in a weird way, 0 and 2 came from the wording. Cool? 11. Okay. Blue, 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 blue. And it has third degree centered at 0. Third degree centered at 0. Third degree centered at 0. What did I build so far? Third degree centered at 0 for, what's this guy? F of x. I have the third degree centered at 0 for f of x. What am I, I'll just hide this for a second. What am I supposed to do? Reword this Shakespearean stuff. What does it want me to do? Take the integral of it. Now, if I take the integral of it, do you agree this goes to an x? X squared, x cubed, x to the 4th. You guys okay with that? Just so ignore all my stuff here. Okay. Do you agree? That goes to this, this goes to that goes to this, I did it. Very important. Now here you can't mess it up because in multiple choice, how far did they go in multiple choice? Third, because what did they ask you? Third. Very important note, on free response, and I will grade like AP, on free response, if you write this and circle this in your free response as your answer, you're going to get marked wrong. Why? They said, give me P3, and you didn't listen to them. You gave them P4. Then you're going to call Mr. AP or Miss AP and say, but I gave you a better approximation. Didn't you want it to be better? No, I didn't want P3. You went too far. But I had the time. It's okay. I know it was a time test, but I had the time. So I gave you a better answer. You didn't listen to me. But, you told me to clean my room. I cleaned my room and the bathroom. You're mad at me? I wanted you to clean your room. I did. And the bathroom. I didn't ask for the bathroom. They will count you wrong. What? No. Oh. Okay. Yeah. You're multiple choice. I don't know what P3 means. So I think it's up there somewhere. Just take one. Thanks. That's like back in like 5th grade. If you're like supposed to round to the second decimal place, you're just like kind of wrote 10 decimal places. You do the rounding. Yeah, no, you're wrong. That's what the whole point was. Oh, hey, there's 12. You can look at 12. I just want to see if there's another multiple choice. Okay, multiple choice here. Blah, 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 blah. Alternating series. It will tell you. I don't have to do Lagrange. There's no K. Alternating series. So, plus red, minus red, plus red, minus red, plus red. Stop. Next guy's my air. Now, anywhere in this question, does it tell you go get your approximation? No. So who do I not care about? Red or green? Who do I not need to do anything with? Red. You could spend some time getting your approximation, but it doesn't say what's your approximation. It just says talk about the air. So I built third degree. Where's my air come from then? Fourth. And it is exactly the fourth dude. You guys okay with that? No K talk, no like who's max and all that stuff. It is exactly the fourth dude. So, is this the yellow part of the fourth dude? Is this the green part of the fourth? Wait, know what I was trying to show you? I was thinking yellow, green, blue. But what did they already give me? Is it already blended? Okay, so can I literally just plug in the fourth dude, 4 into my N, and I'm plugging in 9/4, so 9/4 into my X's. 4 into my N, and then 9/4 into my X. I get that. There's your answer. They don't ask this, but I would. Am I an overestimate or an underestimate? And I'm an underestimate because if the green guy was a positive, that means my red something ended underneath, because what's the green help me do? Back over it. Merrick. Correct. But when they do air, when you do air, if you did 1.9 minus 2 or 2 minus 1.9, the positive or negative, when you talk about air, you can always just go absolute value. You can't do that for correct. If I had 1.9 minus 2 to the third, 1.9 minus 2 to the fourth, alternate. Yep. Okay, so I skipped 12, but I answered it for you. I hit 13 and 14. Ooh, one more, and then you can go look at 12. 14. I want the 5th degree. Do you understand why I circled the 6th degree statement for K? It told me to stop at P5. So the next guy is the 6th guy. So the middle thing there is your K. What you and I talked about is K. So there's your K. 6 factorial, something to the 6. I am centered at 0, minus 0. And I'm trying to get 1.2. 1.2. Cool? So last class I got through everything but 15. This class I got through everything but 12. But is my answer key there for you? Okay. Zach, what's up? No. Okay. Okay. We good? That's tomorrow. Okay. Cool. No kiwi. There's something tomorrow, is like a homeroom activity. I am not ignoring it. I created my test before the homeroom activity came about. I super duper value the homeroom activity. We're doing it on Monday. Hear me there? Okay. What? It's a second, third period combo tomorrow. But they curveball me when I had this plan first. Then they said, here's what you're doing in second hour. And I'm like, I don't have time to do it tomorrow, so I'm doing it Monday with you guys. Those of you who know what it's about, it's the no hate stuff. Very important to me. It's not me just like poo-pooing it. I'm doing it on Monday with you, okay? I care.
Thank you, Bulk.
Yeah. Let's see how long my video is.
8 hours. The recording for